Hi, welcome to AP Chemistry. This is Ms. Dahlberg, and we are on our last problem in our thermochemistry free response practice. And our last problem has this reaction. This is ethane gas or acetylene gas reacting with hydrogen to form ethane gas. And so we're given some information. We have some entropy information, which we don't really need for this problem, but we are given some enthalpy of formation for some of those compounds, and we're also given bond energies. And we're given bond energies for different bonds, and we're asked to calculate the value of the triple bond in the carbon-carbon bond in the ethylene or ethine molecule. And so if we look at this, this is carbon triple bonded to another carbon, and hydrogens are attached to each of the carbons. If you notice, each carbon has 4 bonds. It's very typical of carbon. And the hydrogens are attached. Hydrogen can only have 1 bond. And then that reacts with 2 hydrogens. So I'll draw 2 molecules of hydrogen. And when they react, you get 1 molecule of ethane. And all of these carbons, each of the carbons, so carbon is attached to 1 of the carbons and then 3 hydrogens. So every carbon has 4 bonds. Okay, and we want to know what's the value of the bond energy in that carbon-carbon triple bond. And so the relationship, we know that all the bonds broken require energy, and all the bonds formed release energy, and we can add those 2 together. That gives us the enthalpy of our entire reaction. So in order to form this, we kind of have 2 steps. Step 1, find the enthalpy of reaction. And step 2, use that enthalpy of reaction to find the bond energy in that triple bonded carbon. So step 1 is to find what's the enthalpy in this reaction. So I want to know what is delta H of this reaction. And I'm going to get that by using the enthalpies of formation. Sum of the enthalpies of formation of the products minus the sum of the enthalpies of formation, the reactants. Okay, and so to find this one, I am going to look at the products. I have my balanced chemical equation. The balancing wasn't too hard. My product is C2H6. And if I look on my table, the enthalpy of formation of C2H6 is negative 84.7. So negative 84.7. And that's kilojoules. Not kilograms, kilojoules. And I would need to multiply it by the coefficient. And if you look over here, the coefficient of my product is 1, an understood 1. So I'm done there. Minus the heats of formation of my reactants. So if I look, I have 2 different reactants. I have hydrogen, and I have this ethine gas or acetylene gas. And so If I do the acetylene gas, the heat of formation is given to me in the table, and it is 226.7. Now I have it multiplied by the coefficient of 1, so understood 1, and then I'm going to add to it the heat of formation of hydrogen. Now hydrogen is an element, and the heat of formation of any element is 0. And so if I had a value there, I would multiply it by 2 because of the coefficient, but my value that I would multiply 2 by is 0. So in other words, I don't really need this. This kind of goes away. Okay, so if I add those two together, I get the delta H of that reaction. And the delta H of that reaction turns out to be negative 311.4. And that's kilojoules per mole. Okay, so now I know my delta H of reaction. I'm going to use this from the overall reaction to figure out what is the bond energy of the carbon-carbon triple bond. So now, part 2 of D, if I take this enthalpy of reaction from right here, and I use it, so I have the sum of the bond energies for the bonds broken minus the sum of the bond energies of the bonds formed. So when I do that, I have negative 311.4 as my enthalpy of that reaction. I calculated that in the last step. Now I need the bond energies of my bonds broken. So let's go back up and look and see. In my reactants, what are the bonds that are broken? I'm breaking 2 carbon-hydrogen bonds, 2 times the bond energy of the carbon-hydrogen bond, plus, put that in brackets, plus, I'm also breaking a carbon-carbon triple bond. So I have 1 bond energy of the carbon-carbon triple bond, plus I also have the bond energy of these 2 hydrogens. And so I have 2 of those, so I have 2 times the bond energy of the hydrogen bonds. Okay, so minus the bond energies of all the bonds formed. And if I look over here, I have 2 types of bonds formed. I have 6 of these carbon-hydrogen bonds and 1 carbon-carbon bond. So I have 6 bond energies of the carbon-hydrogen plus 1 bond energy of the carbon-carbon. And I'm going to close that out. And let me make that a little bit bigger. Plus bond energy of a carbon-carbon. Okay, so now let's figure out the numbers and put in some numbers and solve for our unknown. So if I know this is negative 311.4 kilojoules, and that equals 2 times what's the bond energy of my carbon-hydrogen bond? And so if I come up here, I'll look. Oh, it's 400. 2 times 414 plus the bond energy of my carbon-carbon triple bond. Now that's my unknown. That's my X, the thing that I don't know. So I'm going to put an X there. The next one is 2 times the bond energy in a hydrogen-hydrogen bond. And so coming up here, here we go. There's our hydrogen-hydrogen bond, and we have 436. Okay. Minus 6 times the bond energy of my carbon-hydrogen bond, and that one is 414. 414, not just 14, plus my 1 carbon-carbon bond. And if I look at that, that's 347. So plus 347 kilojoules. And I will close that out. And it's time to start adding them all up. And when I do and solve for X, I get X, which is the bond energy of that carbon-carbon triple bond. That bond energy is 820 kilojoules. Okay, enjoy your day. Talk to you later. Bye.